So let's look at the types of catalysts and also the catalytic reaction. So types of catalysts, we have maybe catalysts in gas form, we have also catalysts in liquid form, and we have catalysts in solid form. And catalysts can be from different substances, and that substances can be in organic or also inorganic. Okay, how does the catalyst work? Basically, catalysts can be in homogeneous form. So previously, I told you that catalysts can be in different states, whether it is in gas, whether it is in liquid or in solids. So in this slide, there is another definition of whether catalyst is in homogeneous or heterogeneous. So the meaning of homogeneous is whereby the catalyst and the reactants are in the same phase. So for example, if the reactants are in gas form, so for example, maybe steam to react with uh, what? CO2 maybe. So both steam and CO2 is gas. So maybe it use another catalyst, which is maybe carbon monoxide as catalyst, for example. Okay, so that we call that as a homogeneous catalyst. Or maybe both liquid, both catalysts and also the reactants in liquids, for example. Maybe the catalyst is acid sulfuric, which is in liquid form, or and that acid sulfuric would actually catalyze reactants, which is also in liquid form. So we call that as homogeneous catalyst. And what about heterogeneous? So heterogeneous is actually whereby the reaction system involve different phases of catalyst and also the reactants. So for example, catalyst may be in solid form, whereby the reactants may be in liquid or in gaseous form. Okay, I hope you guys can define what is homogeneous and what is heterogeneous reaction system between reactants and also catalysts. Okay, some example of catalysts. There is acid-base catalyst. What does it mean? Means that catalyst has its own pH type, which is whether it is in acidic. It may be a little bit acidic or maybe very acidic, and there are also catalysts which is a bit basic or a bit alkalized. Okay. There are also catalysts in which that involve in in sunlight. It only works whereby the sunlight is there, and there is also a catalyst which is happens in electrochemicals, in catalysis, electrocatalysis. Okay, so the role of catalysis in national economy, I hope that actually maybe you can just read on your own. You can also find what are the roles of the catalysis in other reading materials. Okay, let's look at the advantages of catalytic process. One of the advantages, it would achieve a better process economics and also productivity. Why? Because it will increase the reaction rates, so the reactions will be fast, and it will simplify the reaction steps, so meaning that it would cost less, and the reaction will be carried out under maybe lower temperature and also pressure. So if you carry out a reaction at lower temperature and pressure, so the energy consumptions would be lower as well. So these three things that actually make the your reactions to produce a product to be very economical and also very productive. Another advantages is to reduce maybe waste, and also it may make one products to be better. For example, if you do use that catalyst, maybe that product won't be produced that well. So if you use certain types of catalyst, the product will be produced in terms of yield and selectivity, which is very good. Okay, maybe another advantages is also the process which has catalyst. It has a better control in terms of safety, in terms of the conditions, reaction conditions, and etc. And a lot more. So you can find the advantages of using catalyst in one reaction, in other reading materials, or in other journals. Okay, let's look at some of the research of that involves catalysts. So we call these as research in catalysis. So some of the research are photocatalytic reaction. You can also involve the research that that involve catalysts, which is in transition metal, also catalysts which is in homogeneous, and the catalysts that involve the biomass conversion into energy or something useful. Okay. All right. Basically, if we talk about the research catalysis, we actually need to deal with the kinetics and also the mechanism. So we also need to deal with how to develop that catalyst. Okay. So meaning the catalyst developments is you need to select what are the materials, what are the synthesis methods, what are the properties. You have to look at the stability of the catalyst, you have to look at the durability of the catalyst and also the compatibility. And once you develop that catalyst also, what you need to look at is the different techniques on how to characterize. Characterize means to study the behavior of that catalyst, whether it is stable in long term, whether the durability is also long or short, or maybe what the behavior, different reaction conditions, what are the behavior of that catalyst, so on and so forth. So there are many aspects or many parameters or the parametric studies that can be studied on the catalyst itself, or can be studied on the catalysis field itself. Okay, other catalysis field that you may want to further study, maybe in reaction modeling. So basically, kalau we talk about the reactor modeling, we can study on the step by step of the reaction itself. So you may study on the quantum mechanics and the physical chemistry of that reactions. And other thing is that maybe you further study on the mathematical interpretation and also representation of reactions that might relate to the reactor design. which also involve the structure and the efficiency, which involve heat and mass transfer. Seriously, a lot of things that you can study. Okay, and if not, you can study on the catalytic process, which involve more on the heat and mass transfer, the energy balance, parametric studies, the reaction conditions, etc. and etc.